When you design an autonomous system, making your system understand what it has seen and how the object is moving are crucial so that the system can take reasonable actions. For instance, a simple task could be designing a robot with a camera and making the robot track an object using the video captured by the camera. For identifying the object by color, you can use color-based image segmentation covered in the last video. However, if the object has a visual texture, a technique called image features can help. Today, you will learn feature-based tracking of a predefined object in a video. First, you will explore image features, and then learn how to locate an object with a region of interest. We will do this using feature detection, description, and matching. Finally, you will see how to track the object represented by feature points in the IOR. Before addressing feature matching, let's understand what image features are. Image features are distinct patterns found in an image, such as blobs, corners, and uniform intensity regions. They must be something that differs significantly from their immediate surroundings by texture, color, or intensity to help uniquely identify parts of the image. To begin with, you will first read a video in MATLAB. A video is a set of image frames captured one after the other. You will work initially with just one frame from the video. Let's see frame number 250 using the video reader object. To track the object, you first need to locate it by, for instance, manually marking it with a region of interest, also called IOI. Sometimes you may be lucky to have a pre-captured image of the object. Here, you can use the image as a reference, find its features, and further identify the object with feature matching. Let's go start with finding features that use blobs. Let's see this one. When you plot the output, you see the location of the detected feature points, as well as an associated circle indicating the scale of the feature. The next task is to distinguish a feature from the rest of the image. You can use the extract features function to get representation for each point and its immediate surrounding pixels, known as descriptor. Once you have the descriptors, the next task is to find the ROI that has the MathWorks logo. But to do this, you need a reference image to match the features and know the location of the logo. So, you use the theme detector and the descriptor to get features, use match features function, and then display them. You see here that there are some wrongly matched features called outliers. To eliminate them, you use the estimate geometric transform 2D function that specifically provides us the index of correctly matched feature points, called inliers. And to get the ROI, this variable tphone will help you with the necessary information. You then loop the video by using read frame to get the next frame, detect, extract, and matching features, and run the code. You see the location where the logo is detected. There are various types of detectors and descriptors. Some are scale independent, while some are not. Selecting a method that's scale independent is necessary to detect a feature at various zoomed levels. Image Registration Estimator app in MATLAB provides an interactive way to test different methods, tune parameters of a selected method, and eventually generate MATLAB codes. After successfully found the inliers, the next step is to track this object in the rest of the video. You can extend the same technique of matching features on every frame. However, You can see that the inliers change across frames and the IOI is sometimes inaccurate. A more stable way is to use the point tracker technique to track the object represented by features. You can initialize a point tracker with inliers and then loop the rest of the frames where the point tracker can automatically find the new location of the inliers. Results show the point tracker also works when the logo moves in zoomed in or zoomed out frames. In case you do not have a pre-captured image of the object of interest, or the reference image does not have a good quality, you can mark the region of interest manually in a video frame. You then initialize the point tracker with the features detected in the IOI and run the tracker for the rest of the frames. A few points to note here are that feature-based tracking is sensitive towards lighting variation, autoplay rotation, or articulated motion. Also, to track the object over a long period of time, you need to periodically reacquire points to reset initial points of the tracker. Moreover, the tracker may lose the object if the object of interest is abstracted from the camera view. In such situations, you can consider using Kalman filters to help predict the object locations. You can check out more about Kalman filters in the description. Before we close, we have a small exercise. The exercise is to recover a rotated video based on the feature detection, description, and matching framework using Simulink, and you need to add the codes missing in the blocks. A short summary. You learned how to perform feature-based object tracking for a video. We discussed deciding the detector and the descriptor depends on type of the data, and that the image registration estimator app can help test the different methods. If you meet any questions related to the video or the exercise, please reach out to us at roboticsarena@mathworks.com. Thank you again for watching this video and see you in the next one.